This video program is designed to present an overview of the basic operation of the OCL400 brake lathe. It is not meant to replace live training or the detailed instructions available in the operation manual. For live technical training, contact your local Hunter service representative. If you need a replacement operation manual, contact Hunter at 1-800-448-6848. Before using the OCL400, read the operation manual. Keep the operation manual available for use in the service bay. Wear OSHA-approved safety glasses. Never wear loose clothing. Keep your hands and fingers clear of rotating assemblies. Do not use the lathe if it is damaged or requires service. Always use the OCL400 as intended. Resurfacing rotors on the vehicle can not only save a great deal of time, but for many applications, it is the only effective way to fix brake problems. For example, removing hubbed rotors on many four-wheel drive vehicles can be very time-consuming. In fact, for some of these vehicles, the time needed to remove the rotors, mount and resurface on a bench lathe, and then install them back on the vehicle can almost double the time required to complete a brake job. Save this time and simply do the resurfacing on the vehicle. Resurfacing rotors on the vehicle also allows you to accurately fix runout and thickness variation conditions and fix them long-term. On today's sensitive vehicles, pedal pulsation, noise, and vibration conditions are often due to excessive lateral runout. Runout at the rotor head, runout at the friction surface, and runout at the mating hub may all combine to exceed factory limitations. The only way to reveal this stacking runout and remove it is to resurface the rotor with it attached to its mating hub. This will guarantee the friction surface is true and perpendicular to the wheel's rotational axis. Vehicles with captured rotors also create a problem. Like the four-wheel drive vehicles previously described, removing captured rotors to resurface on a bench lathe makes the brake job all too lengthy. The new GM Canyon and Colorado also present the same problem. Resurfacing captured rotors on the vehicle has always made the most sense. Position the vehicle on the lift rack according to the manufacturer's guidelines and chock the wheels. Perform a thorough brake inspection. During this inspection, be certain the rotor and hub assemblies will rotate without excessive friction. This is also a good time to check all suspension, steering, and drivetrain components. Measure the thickness of the rotors to be serviced and be certain the machining will not bring them below the manufacturer's specified minimum thickness. For these specifications, refer to Hunter's Form 3640T. Remove the caliper and suspend it clear of the rotor assembly. Don't allow it to hang from the brake line. Also, if so equipped, note the location of anti-lock sensors and associated wiring. Inspect and clean all the appropriate mounting surfaces. This includes the hub flange, its mating surface on the rotor, and the outer mounting surface on the rotor head. Align the hub adapter with the wheel studs and secure it with the vehicle's lug nuts. Tighten the lug nuts to approximately 40 foot-pounds. Never use an impact gun to attach the adapters. If the factory lug nuts will not work, use the nuts included in the mounting accessory kit. Next, roll the lathe into position and align the index bolt on the compensation plate with the index hole in the adapter. Then tighten the drawbar with the 22 mm wrench provided. To locate the correct ring flange for the vehicle, use the application guide, or simply choose the adapter that fits over the hub and is the correct bolt circle. In this case, the vehicle requires the number 794 ring flange. Each flange is stamped with its part number for easy identification. Position the flange onto the studs and attach it with the vehicle's lug nuts. If the factory lug nuts will not work, use the nuts included in the mounting accessory kit. Tighten the nuts to approximately 40 foot-pounds. Rotate the assembly so the index mark on the flange is straight up, and then align the index mark on the hub adapter with the index mark on the flange. Using the Allen wrench provided, secure the adapter with the 3 attaching bolts. Next, position the lathe and align the index bolt on the compensation plate with the index hole in the adapter. Then tighten the drawbar with the 22mm wrench provided. To locate the correct adapter for the vehicle being serviced, refer to the application guide, form number 4257T. This particular vehicle requires adapter number 3219. Align the adapter with the wheel studs and secure it with the vehicle's lug nuts. The lug nuts should be evenly tightened to approximately 40 foot-pounds while making sure the adapter is as centered as possible. If the factory lug nuts will not work, use the nuts included in the mounting accessory kit. Next, roll the lathe into position and align the index bolt on the compensation plate with the index hole in the adapter. Then, tighten the drawbar with the 22mm wrench provided. Back off the compensation wedge bolt and be certain the cam plate is free to turn. Turn on the power switch and then position the control box upright. Now, press the angle transducer button. When stable, the ready indicator light will turn green. Next, press the compensation button. The lathe will then rotate the assembly 3 times, taking a reading at each position. As each reading is taken, its respective indicator light will turn red. After the 3rd position is measured, the lathe will rotate once more and take a final reading. The runout bar graph now displays the amount of runout requiring compensation. To make the correction, rotate the compensation cam until the adjuster wedge is at top dead center. Then, using the Allen wrench provided, adjust the cam wedge until both center green lights are displayed on the runout bar graph. If desired, any residual runout may be verified by pressing the Test Runout button. The lathe will rotate 120 degrees and then settle. If the runout is within tolerance, a double green light will be displayed, and the RPM display will show a 1, 0, or -1. If not, the runout procedure should be repeated. Loosen the cutter shaft lock bolt and position the tool holders as shown. Then tighten the lock bolt. Disengage the feed by rotating the engagement knob counterclockwise. Now rotate the RPM switch to start the drive motor. Set the speed between 60 and 80 RPM. Using the feed control knob, position the cutting tools fully inboard. Be careful not to crash the cutting tools. Next, loosen the inner tool holder. With the depth knob, adjust the inboard cutter until you can hear the insert just touch the rotor, and stop. Then, while observing the scale, dial in the desired depth of cut. Each mark on the scale is 4/1000ths of an inch. Tighten the tool holder lock knob. Repeat this same procedure with the outer tool holder. Now, adjust the RPM to the desired speed, and then engage the feed. If you know or suspect the rotor may be prone to chatter, depress the ACT button. The ACT feature varies the RPM of the lathe to eliminate the possibility of chatter. In this application, the lathe will have to be inverted for the cutting mechanism to be positioned properly. To do this, loosen the pivot lock and swing the entire unit 180 degrees. Then rotate the control box so that the operation panel is back upright. Even when inverted, the OCL400 can be uniquely operated with ease. All the controls function in the same manner, regardless of how it's positioned. The cutting inserts should be rotated or replaced whenever the resulting surface finish begins to degrade, or if the insert is damaged. To replace the inserts, remove the Torx head screws, attaching the inserts to the holders, and discard them. The required Torx wrench is provided with the unit. Clean the tool holders, and using new screws, install the new inserts securely to the holders. Chips and other brake debris should be cleaned from the lathe using a brush. Never use compressed air. The mounting adapters should be brushed clean as well. Inspect all mounting adapters. Any small nicks or burrs should be removed with a very fine crocus cloth or similar polishing material. Clean all the machined surfaces on the lathe and adapters, and then treat them with a rust-inhibiting lubricant. We recommend a dry lube be used on the tool slides. Clean and lubricate the feed screw. Clean and lubricate the compensation plate assembly. Periodically, remove the tool insert holders and clean the mounting area. Remove the set screws completely and clean the threads. Clean the holders and reinstall. Then be certain the screws anchoring the inserts are tight. Because the tool tip will wear with repeated use, we would suggest that you replace the Torx wrench when required. For additional maintenance information, refer to the operation manual or contact your local Hunter service representative.